No. Okay. How is everybody doing? Tonight we are back with Dan Does Data. I apologize for not letting people know earlier last week that I'd be away. I was traveling, but as a consolation prize, I released my what is going on? I released my video series on deep learning with TensorFlow. I've been working on this project for a couple months with Pact Publishing. If you search Deep Learning with TensorFlow Pact, you'll find it, or you can find this link up here. Let me paste that in here and make it a little easier to read. Right there. It's also in the comments of this video. So this is a fully produced TensorFlow video course. Jeez. That you can check out. You can always check out the free sample, where I sort of give a broad overview of the course and what you're going to learn. You might recognize none of these specific models, none of the specific data, but some of the same ideas that we've been trying to do more recently. But this is with TensorFlow. So we walk through simple TensorFlow, through full models. You get to learn skflow, all kinds of other good stuff. I had no input in the price, but this is pretty standard. So I encourage you to check it out. And if it's something that's helpful for you or your business or your university, give it a look. Let me know what you think. It certainly couldn't include everything, but I think it includes a lot and will get you really up to speed. But anyway, I just wanted to put that out there. This just got published last week. This week, however, we are continuing our foray into Shakespearean font recognition. For well thou knowst. That's right. You might recall previously we had made a simple data set, made a simple model that worked way too well, refixed up our data set by jittering the fonts around, and made a convolutional model that did pretty good. The problem with the convolutional model, however, is that it's enormous. Well, it's not even that big. It just takes a long time to train. Here's the old model there. So I mean, yeah, it's only got like 4 kernels and like 32 dense neurons layer, or 32 neurons in a dense layer, or whatever. You know, that's not that big. But you know, like you really don't need that much because the input is pretty big. It's, what is it? 32 by 32? No, 32 by something. I don't even remember. It's been 2 weeks. Number of rows, 16. Number of columns, 64. So yeah, 16 rows by 64 columns of pixels, of course. So what we want to do is just look at a slice of an image at a time. And let me read in the old data set, and I think this will make a little more sense if I do that first. Let's do auto indent. That's always good stuff. But yes, it's good to be back. I was busy traveling a lot. So it's good to be home again, even though it's really hot outside. Right, get our plotting back. Let's take a look at 5 images, and this is where it'll be a little more clear. So remember, we jittered around a bunch of things. So these images are all over the place. You get to look at like part of an image to see what you're doing. Oh, you know, can I say, hang on. Plot.pcolor.mesh. Can I give it a color encoding? I bet I can. I might have tried this already and gotten burned by it. cmap equals plot.cm.hot. See if we can do that. See if I like that better. There we go. I like that a little bit better. So the white here is hot and the black is not. Let me do that the other way. Hot, reverse. Because normally I look at black text on a white background. There we go. And having some red in between is typically fine. A little bit better than gray. It's a little easier to see the difference. Right. So you can see this whole image here. And like, if you could look at this, yeah, you could probably piece together which font is which as well. But like, you have to look at the whole freaking thing at once. And so you get this giant model. This 16 by 64, even with the convolution where you're looking at a little square and you're taking that same square for a lot of things. You know, that's kind of a lot of operations to be doing. So what I want to do is say you get to look at, I don't know, 16 by 16, basically one character's-ish worth of space. Oh, is this it's rated 16? No, it's at like 10. All right, it's maybe by 10. I was just looking at the tick marks, which you probably can't even see, but there's several here. So maybe by 8, since there's 64 across. I want to look at a small slice, say 16 tall by 8 across. Try to figure out, all right, what is the font based on this, plus the information from the previous block, or maybe plus the information from the previous umpteen blocks. That is, I want to build kind of a recurrent model, but using the image of the letter rather than the letter itself. So you've probably seen recurrent neural networks used with a thing called char RNN, and that's to like train on languages one character at a time. Here we've got like an image of a character, and I'm not training on the language, I want to train on the font. So we're going to have to massage our data a little bit. But the idea is I want to split up this 16 by 64 array into 8 16 by 8 arrays. So I have 8 sort of blocks, each one 8 pixels wide. And you look at the first pixel, that updates whatever kind of internal memory to your recurrent network, which if it's like an LSTM, a long short-term memory, it remembers some things, and then you look at the next block and you say, okay, based on what I saw before and what this is, what do I think I'm seeing here? And at the end, you have some label for the whole sequence, and so you're trying to build up a sequence classification. And this might look like it goes off and that these are all 0 at the end, but in fact, this goes to 70, whereas these all actually end at 64, which right here is this last column. So that's just an artifact of the plotting here, nothing to worry about. So that's the idea anyway. Will that properly work? We'll see. We'll see. I'm definitely going to have to do some lookups on sequence classification. We're going to have to futz around with the data to break it up a little bit, and all this other stuff. So this could be, this might take more than just a day. The idea is easy, sure. If anyone has suggestions on doing sequence classification in Keras, I'd be happy to hear it. Let me do a quick search on that. Sequence classification Keras. And actually, I might have done this before. I think I did some kind of. I futzed around with some kind of sequence classification in Keras. That's the problem when you start like Proj Keras? What am I doing here? Keras RNN, hey, what do you know? Let me just open it up in here. //Keras RNN. So let me look at this old RNN. And is this where oh yeah, this is where I model precipitation and temperature. I was modeling the weather. I was trying to predict the season or something. Or I was trying to predict the rainfall. I don't remember exactly. Input, output, season class. Yes. I was trying to predict the season based on the temperature and precipitation. So that was just a simple, silly model. However, well, that was a model I whipped up in like 10 minutes too. I was proud of that. The question is, what is the input data like here? And I need to make my input data. This is a different. All right, no. This is a different kind of problem. Because here, you've got a season for every. You've got a label for every data point. It would be as though I had a label for every 8 pixel block. I should just leave that image open. I don't know why I don't even. There we go. I just leave this open. This is something I'm always going to need. If I had for every label and like maybe my font was changing all the time, or maybe like sometimes, then it would be important to say, yes, I need a label for every 8 pixel block. But that's not how it is. I have a whole bunch of blocks and then one sequence. So I had done a video, I thought, looking at these RNNs where it was like some airport information. Yeah, here we go. It was a series of words, like from an airport messages, and you had to try to classify. No, that was still classifying what kind of words they were. So maybe that's not it either. You know what? Okay, we're gonna ask the internet. Sequence classification Keras. Guide to sequential model. That's not what I want. Sequence classification with LSTM. All right, so that is something. Let's just click on that. LSTM is warm, man. Goodness. All right, sequence classification with LSTM. So I think this is essentially what we want to do. And you know what? We might just try in LSTM. Here they're doing an embedding first, and they have to learn the embedding. I always find that, to me, that's confusing. I get it that you need to learn that that's part of what you're learning, but I would like to just dump my input features as I have into this LSTM. But maybe I can use this. All my things are the same length, so I don't have to worry about that. Let me just copy some of this. And here they've only got one output class. We've got 5. So that's a little bit different. I don't think I'm even going to use that. So this thing has simple model built into it, which I'm not going to remove. Let's say LSTM. I'm pretty sure that's going to be more relevant than just the... I care about some overall past history, not just whatever the previous guy was. I have no particular reason to believe that the previous block is more useful than some other block. Like, you could probably permute these blocks around and get more, well, no, I guess the previous block might be more useful if it connects to the current letter. So maybe that will matter. Set paste. Right, I'm pasting something, and I don't want to get extra things. So yeah, let me just call this RNN then, rather than start off with the LSTM. Maybe I will also. Interactivation hard sigmoid. I don't even know what that is. Alright. Input length, max length. This is 8. Max features. So this is taking whatever my input features are and embedding them in a space of 256. However, you might recall, if I'm looking at 16 by 8, that's only 128 features. So I think that's a little silly, personally. Let's put this into a space of 32 features. Let's try this. This whole embedding business might not make sense anyway. It might make more sense to do some, this is going to sound a little weird, do some convolutional, small convolution on this 16 by 8 space, and whatever I get out of that, stick that into the embedding. But that's one thing at a time, right? So there it says I'm embedding max features, which is how many input features I have, right? I don't have embedding. I don't even have Keras imported yet, do I? I don't. Let me grab some Keras. Let me make sure I grab these things. Dense dropout activation, layers, embedding in LSTM. Okay. Keras.layers, import, embedding, LSTM, in case I want both. There we go. Let's see if I'm about to get burned here. Yada yada yada. Got my old. What's the RNN? What's the magic RNN? VGD like connet. RNN. Specifying the input shape. All right. Ah, there we go. Okay. That's what I wanted. Can I do that? Can I get embedding? No. From Keras.layers import embedding. There we go. Now I got all the things I need. Well, after I import all this other stuff first. There we go. So here, simple RNN just works with how many things have you got. No, I don't want to tag that. Maybe I do, but sequence classification, right. Max features. You know what, let me just, I don't even know why I'm, just ask the help. That's a much better way to do it. Self. Input dimension, output dimension. Yes, that's what we want. So of course our input dimension is however many features we have, which if I flatten it out, and actually I should do that first, model.add flatten. If I say input shape, flatten, flattens the input, does not affect the batch size. Yeah, well, naturally. There's 8 rows, comma 16. That should make sense. Alright. And then I don't need this, or do I? I feel like I shouldn't, but I probably will. Embedding ought to be able to figure it out. Yeah, it's required. Okay, that's fine. That's fine. We can say 8 times 16. So we're taking 128 things and crunching them down to 32 in some kind of arbitrary way here. And then we have our, let's do LSTM. Sure, for giggles. I don't want 128. That's way more than I need. Let's try that. And we got 5 things at the end. Yeah, that should be good. We don't want binary cross entropy. We want categorical. RMS prop is fine. I don't really care about that. What are my... Just grab my old model.fit thing. Here we go. H equals. Here we go. Train flats. Train labs. No, actually. Let's do that. There we go. Alright, but of course, this business isn't really going to work. I don't need that. This business isn't going to work correctly. Right, because my train flat data is not the right shape. And is not even defined, apparently. Did I not do that? Apparently, I thought I did. My mistake. I guess I didn't get to this last bit here. N rows? Really? I thought I did all this stuff. P test IDX? Alright, I guess I didn't do that yet. Alright, well that just takes a few seconds. That's not a problem. So I gotta grab my data, split it up. I feel like I had a better way of doing this, but whatever, it doesn't matter. So train flat dot shape, what you'll recognize is already flat, so I don't need to flatten it. Right. I was thinking I had to flatten it myself. That's fine. So really, I want to reshape it again. So I have these 8 blocks of whatever I'm dealing with, and I can do that after I specify the model. Reshape inputs into 8 blocks of 16 by 8. There we go. Call it train block equals train flat dot reshape. What do I want? I want 8 blocks. No, I want however many things there are, like 8 blocks by 16 rows. by 8 columns. I believe that's correct. That is not going to do the right thing. Right. What is train flat? I guess I flattened before I did this other thing. Data flat, data, yeah. So I took my flat after I already grabbed my data, which is troublesome. Because if I say data flat dot shape, no, I don't want data flat, just data. There we go. Because this will junk up my rows, but not my. It'll screw up my columns here. Let me rephrase that. If I just do this reshape business, like this, I'm going to get like half of this first row is my first. No, I'm going to get the first 2 rows of this are going to be my first block. But that's not what I want. I want this business over here, right? So I really sort of want to split based on how wide the columns are. So I have to think about the right way to split that up. And can I do it better with just data.shape? Right. Let me just do this. That's data. So that's my first image. Hang on. Let me get the canonical image here. Entry 2000. And I want d. Is there a way to? No. NumPy.reshape for the full documentation. All right. What's NumPy.reshape? Talk to me. So I could. This is gonna be kind of weird. I could read it in Fortran order. So that's reading the columns first and then the rows. I'm not sure what that would mean when I've got. That might read my data points in the wrong order, and I would get like the first 128. Let's see. Yes, the upper left pixel. Let me go back to this image. Oh, I lost it, didn't I? Yeah, I would get the upper left pixel from the first 128 as being my first block of the first guy, and then the upper left pixel of the next 128 as being my next block. So that's not what I want. That's not going to be helpful. Oh, that's going to, okay. There we go, much better. New shape. Take no account of the memory layout, only for the order of indexing. Yada yada yada. Indie array.reshape. It's not always possible to change the shape array without copying the data. That's not what I want. Okay. But I think there's a way to not concat, but I seem to have lost my. All right, that's cute. Sorry, I seem to have lost my cursor there, and I didn't actually have anything over there anymore. So while I try to figure this out, I'll re-import these things. So that's gone right now. I want to split. I want to chunk those up, so I sort of just want to split my array on a particular index. So is there an opposite of concat, I guess is the question. Right? That's sort of not be got concatenate. Axis along which arrays should be joined. MA doc. Okay, that preserves input split. Here we go. That's what I want. Split an array into multiple subarrays. Array must be subdivided. Int or 1D array. Integer n, then array will be divided into n equal arrays along axis. If such a split is not possible, an error is raised. Alright, so I think that's what I need to do. And can I call d.split? No. D is not a thing anymore. Right. But you can't call it anymore. That split question mark again. Whatever the array is, ARY, it's short. Indices are sections, and the axis. Indices or sections is an integer n, that's how many pieces, and that's along which axis. Okay. That is what I needed to know. So d.shape, just for reference, is this many. So I'll say numpy.split d into 8 pieces. Axis equals 1, say. Oh gosh. What does that give me? Nope, that didn't work. List object has... Oh, it gives me a freaking list. Jeez. Oh my gosh, oh my gosh. That might be 16 by something something. Div0.shape. Div1.shape. Okay. But of course, in my actual data, I'll be having to one-up the index since I have one more entry along which I wish to split. Right. So I'll say axis 2. And let's, so we don't go crazy, try to make sure that we're plotting the right thing here. Let me grab... Let me test splitting. Test blocking up data. What is it? It's only 6:30? Plenty of time. Plenty of time. Alright, let's change this to numblocks. Let's go back down, up, down. Lost control where it was. I'm on the next. Problem when I change a tab and I don't even realize it. It's okay. Numblocks. Numblocks. Blocked D equals numpy.split D numblocks axis equals 1. And of course I'll have to stuff this back into a new array. I don't know why it returns a list. That's weird. Is there a way to say don't return a list? Subarrays. List of ND arrays. I just find that strange that I, you know, don't get an array back out. Exceeds the mentioned array lengths and empty summaries recurrent corresponding. Yeah, whatever. That's just kind of irritating that I'll have to store all my memory again, play this game, yada 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 yada. Just a little dumb. A little dumb. Yes. So we do that. Oh, nope. Do that, then that. There we go. And then we do blocked D of I. Alright, so it's important to kill this. And the question mark is yes. These look like they're forming... Yes, this is something. There's the W. There's part of an O. U. That looks like a word. Is this like... Oh, that should be right. That should be fine. Does that look right? Oh my gosh. Tell you what, let me do this the other way here. see if I can get a little bit more. Yeah, something wound, right? Alright, so maybe this data point is different. Whatever. That's fine. Okay. Oh, did I say D was 0 in this case? Whatever. That looks like a word. Right? There's a U, there's an N. Okay, so we are chunking it up correctly when we do this. And then the question is, how much memory am I going to eat up when I do this? So I'm using up 15% of my memory, apparently. Which is interesting. I thought I would have been using up a lot more. That's fine. I say numpy.array, numpy.split. I tell you what, let me d equals, that's 1, 2. Let's see if we can make it work on 2, right? In fact, let me do this over here. I should make it d first. 2000, 2002. Axis equals 2, just to make sure that it can work when I have, when I have multiple data points. There's 2 of them. That tells me what column I'm on, so for j in range 2. So if I do this, yeah, well that's we're getting there. What is con? Con.shape? 2, 8, perfect. J, that, perfect. Inconsistent use of tabs and spaces. Yeah, whatever, pal. Let me just go ahead and kill that. Ah. Blocked d.shape. Right. D of 0.shape. 2, 16, 8. What? This is a little weird. So I was expecting not 2 16/8. Do I still want num axis equals 1 maybe? I didn't think so. That's very strange. Right, what is d.shape? Let's just start there. 2, 16, 64, right? That's what I have there. Oh, I see how this worked. So it splits all of these, so I get the first block. Right, I see what happened. I get the first block in the first index position, the next block in the next index position, but all the data points have the first block. All the data points first blocks, a lot of inheritance here, are in the first index of whatever this block to D output is. What a headache. Yeah, I understand now. This is that's irritating. Here, let me kill this. That's in the way. Maybe I can learn something more about splits, and there's something that will actually split array splits, split an array into multiple subarrays of equal or unequal size. Okay. H split. Oh, what's this? That's actually kind of cool. H split, V split, D split, stack. I didn't know we had these things. Let me just look up array split. Maybe that's more what I was looking for. Array split. Split. Splits an array into multiple subarrays. Let me see if this does what I want. That shape. You were supposed to give me... Why? I thought you were supposed to give me the same thing. C also allows indices of sections to be an integer, and that does not equally divide it. Oh. That's what I get. Should have read a little bit more thoroughly. So I want... That's irritating. Column-wise... So maybe H split? No, I think D split. Because I technically have 3 things. And the depth is sort of like the third axis. And here I just need to say indices or sections. I don't need to say axis, but it's going to do the same thing. H split is equivalent to axis 1. The array is always split along the second axis regardless of the array dimension. Yeah, this is going to be the same. He does. Yeah, I mean, this does the right... It's going to do the right thing. If I say D split and I give it D comma A. But I always get a list, which is irritating. And the final list is all my second blocks, which is just not what I want. Right? I want the first data point, all those blocks to be together. Which is why I just kind of wanted reshape. Is there anything I'm missing? Not stack. Join a sequence of arrays along a new axis. Well, I guess that actually could work. If I did a split on axis 2, stack arrays in sequence depth-wise, and then stacked them properly, right? That would work. Let me split array. Let's look this up a little bit. NumPy split array. Array manipulation into n chunks with NumPy, whatever. Okay. How do you split a list into even sliced chunks? Yeah, so this is good, but you get a list back. Array split, split, H split, split. Yeah, that's still irritating. I want an array back. Is there a way to use reshape that I'm misunderstanding? Maybe. Num.split, split, num.array split. Well, this guy wrote an iterator. That's kind of cool. Not really what I'm looking for, though. Return a contiguous flattened array. Maybe ravel is kind of what I want. Move axes of an array to new positions. That might actually be what I'm interested in. Roll to specify an axis backwards to analyze a given position. I don't know what that means. Change the number of dimensions. Broadcast, at least. View inputs as arrays. Broadcast 2. Expand, squeeze. Removes a single dimension entry. Expands the shape of an array. Maybe that's what I want. Insert a new axis corresponding to a given position in the array shape. Let's see. I'll tell you what. Random.randint. And let me just say that I've got supposedly 10 numbers, and the shape is going to be 2, 16, 64. As though it were D. Nope, screw it, I'll just use D. That's fine. Oh, You know what? No, that's not what I'll do. A range 2 times 16 times 64. And reshape. There we go. There. So now I have all the numbers 0 through 2048 minus 1. And now on this, I can do expand dimension, right? NumPy.expand dims. This is going to say the axis along which to expand. But I don't say how much. Number of dimensions is 1 greater than that of the input array. I don't think that gives me quite what I want. Maybe that's not it. That just adds sort of an empty dimension. Move axis. Other axes remain in their original order. I mean, I could move the axis, I guess, then do something horrible. By that move axis. Source destination, intersequence events. Original positions of the axes to move. These must be unique. Okay, I'm definitely going to need an example to see what the heck you mean. 0 and -1. Swap axes. Interchange 2 axes of an array. Maybe I just want to swap axes. B.shape. I just want to swap these axes temporarily, right? Does that even make sense? 1 and 2, right? A1, 2. This is just A. Yeah, so this is going down, that's going across. That might be enough. Well, do that, then reshape, and then do my thing here. Reshape 2, 8, 8, 16. Right. So let's get the first chunk here, then there, and then the next chunk, and then the next chunk, so on and so forth. What? Stop being a jerk, okay, man? Except not dot shape, and then I swap the axes back. I moved the 16 to the front, I think. Which 8 is which is the question. Swap axes. Oh, that's not right. Say B equals this. And say B dot swap axes. Or no, not B dot swap. NumPy dot swap axes. We're probably not going to finish this. Just setting up the data for RNNs is a huge pain in the butt, it turns out. 1, 3, I think is what we want. Let me see if that's vaguely correct. You know, I should just do this with the actual input data, really. What's B? Here, I'll make this D instead. There we go. Yeah, okay. And I said NumPy dot swap axes. So let me do that. What am I doing? Shape. C dot shape. Okay. Except, no, that's not right. Right, I want there to be 8 blocks here 16 rows and so many columns. So it's like either 16 needs to be here, no matter what happens. Which one of these 8s needs to be in this last chunk is the question. So I'm going to redo that. There we go. This is going to be C of G I. Somehow, my space has disappeared. Don't know how that happened. Alright. Okay. Much better. Hey, would you look at that? Would you look at that? Here's the first word, first data point. Here's the second data point. So that actually worked correctly. Now I just have to remember what the heck I did. So we're not using split. We're doing this somewhat goofy swap axes business. Let me change this to B. And then C just equals this. Alright, so we'll at least have our data set up for when we get to this. Okay, let's just run this whole little business. Okay, yes, and we are reading in our data correctly now. Wow, this is you really don't get to see the top of this sometimes. Oh well. It'll only make our model stronger, right? Or less likely to overfit. So we need to do that whole hootenanny for this. So I'm irritated that swap axes is not part of it, just an array. Is it? Oh, it is. Never mind. Never mind. I take back everything I ever said. So let's see. Data block. Let's just do it this way, because that's how you do things. Data.swap axes. .swamp axes. Got a serious problem with swamp axe. .swap axes. 2,3. Here we go. Except I don't need D here. There we go. That should work fine. No attribute swap axes. That data was not type data. Yeah. Oh. I'm missing one paren. Invalid syntax. And that paren is over there. Total size of new array must be unchanged. I got news for you, pal. Total size is unchanged. You're full of shit. Hang on. Okay. That's an irritation. Oh, it's not 2 anymore. Right. It's whatever it needs to be. There we go. Data block to shape. Great. Yes, that should be fine then. So let's go up to wherever I make my data before. Make our data the same way. And I'm changing flat to block. Just do the same thing here. There we go. We might be able to actually run a model. Let me make sure I actually input this model. That this actually can work. Okay, that actually runs. That's good. train block, train labs, batch size, number epochs, whatever, validation data, verbose. Let's see what this happens. Let's see what happens. It's gonna take a little good time to compile first. And if it blows up in my face, I will look at it for just a couple minutes, and we'll come back to it next week. As always, setting up the data for these things is half the battle. So that's good. I didn't need to use move. I could have used move axes to shuffle them around, but swap axes ended up being a little easier to understand. So I'm glad that worked out without too much trouble. I don't often use the split and swap axes. Usually reshape is enough to get my do whatever I want to do. So what does our model look like? It's pretty simple. We are embedding our my 8 by 16, so 128 pixel space into 32 features. So you can, honestly, I like to think of this just as a sort of like an 8 neuron or 32 neuron dense input. I don't know why there'd be anything other than this. But then we have in our LSTM, long short-term memory, a recurrence where that can sort of remember things from far off in the past. And we've got 32 neurons there, sort of is how you think of it. We're producing 32 values. We, during training, drop half of those, and then just use that to compute which of our classes are 5 scores for the output fonts. So we're coming directly out of the LSTM. We could have additional dense layers. We could have a convolutional layer before going into this LSTM, all kinds of things. I suspect that's what I'll be doing instead of this embedding. Once I get something running, that's the only goal. Gosh, this takes a long time to compile. I hate that. It's not even a big thing. If it takes the whole time to compile, well, it is what it is. What do I got going on? What's taking so long? I mean, the video encoding takes up a little bit of my... Oh, CUDA FE. CC1+, CUDA FE. Is it done? No, CUDA is still running compiling. But it's not getting as many cores as it could. Probably because I'm streaming at the same time. And this has to be done... The compilation has to be done on the CPU, essentially. So there's just no way around that. If only there was a progress bar on the compilation. So I will just take questions from the audience now, if there's anyone who's got anything. If not, that's okay too. Again, while we're waiting on this, for anyone who missed it earlier, oh, and I forgot to hit the Reddit button again. I always do that. 1 second. For anyone who missed it earlier, last week I did not have a Dan Does Data video, but I did release a published video series on Pact Publishing, Deep Learning with TensorFlow whole video course that'll introduce you to TensorFlow and sort of hold your hand, help you install it, give you some code to get started, and walk you through a novel research problem and model. So it's a totally new, it's none of the video or anything you've seen here, totally new models. And what I think is one of the best things is it's models you won't find anywhere else on the web. I didn't just take a standard benchmark. You walk through a new series of problems with your model. So you can really get a sense for, oh, this is something totally unique and really helps you learn. I think that's one of the strongest points about it, though. So you can check out the free sample, which will tell you a lot of what I just told you and tell you a little bit more in detail and give you a sense of what the video is like. And this is a whole video course, so you try it out, see if it's good for your, what is this? See if it's good for your division or your department or just something that you want to do as an enthusiast. You can buy just this video. Pact also has a thing where you can subscribe, apparently. I honestly haven't checked that out. If you like that, let me know. Maybe I'll consider that. That's just while we're waiting. Oh no! Bad input argument. Wrong number of dimensions. Expected 2 got 4. Boy, oh boy, oh boy. So something went wrong here in our input as expected. Like you do. But it compiled at least. That's a plus, right? So this is the right number of inputs. You know what? I don't really want this embedding. Don't want to deal with it. So I'm not. Instead, input, no, LSTM. I can have an input shape, right? Interactivation, I'm surely I can. Oh. Let's just borrow this. There we go. I mean, it should still be basically the same, except I'm going to have 8 instead of whatever it says. Not n rows times n cols, but n rows times num blocks. Not num blocks. No. Block size. Where do I make my data? I make my data down there. Num blocks, block size. In fact, block size should really be what I create. This is just to be n cols divided by block size. There we go. Right, but this is a convolutional model. Sorry, it's not a convolutional model, but I have... Or this is flat, excuse me. Oh boy. Oh! Oh, no, I'm an idiot. I'm an idiot. I'm an idiot. Nope, nope, I don't need to do that. Hang on. I do still want that. Oh gosh, the problem is, of course, not that my embedding is terrible, but that the data I'm putting in, you might recall, train block has way more than 2 dimensions. It's not flat. Right? It's not even flat in that region. So I'll tell you what. I don't want to just flatten it all out though. Oh, but I can flatten within. Right. Let's see. See if I can reshape this one more time. I really like that though. Data block flat is data block reshape -1, 8 blocks, comma 8 times 16. There we go. There we go. So we're gonna do this, and anywhere I see block here, replace block with block flat. And we're going to do the same thing here. Why? Because we can. Okay. So I created data block flat. Now let's create test block flat, train block flat. Now we can compile. Ah, no, it doesn't like that. But I got 3. Alright, so that's weird. That's irritating. Because I thought the embedding was supposed to handle this issue. But it is now 7 o'clock. Our data is not quite set up. Is there something stupid I don't realize? Input length equals 10. Turns positive integers, indices, into dense vectors of fixed size. Oh, you know what? I guess I do have positive integers. But mine aren't indices, so I really shouldn't even have them. I honestly shouldn't have an embedding anyway. I'm dealing with pixels, actual values. So embedding is for when you just got a whole bunch of indices into a list of words, instead of using that many indicator variables. Which, you know, I get that that'd be a silly thing. Input shape equals -1, comma, num blocks, comma, 8 times 16. Okay, well, let me just try that. No, I didn't like that. Didn't like that at all. Hang on. Is it not a fan? If I want to make a new sequential model, that should not take that long. Ugh. Okay, here we go. Input shape is an unexpected keyword to LSTM, which is kind of annoying. So, that's irritating. I really don't like that. I should be able to do that. I should not be forced to do an embedding if I don't necessarily want an embedding, right? Keras RNN, how did you handle this? How did you handle this? Simple RNN accepts an input shape. LSTM does not. That's crazy. Wait, no, hang on. LSTM is here. Oh, hell. One of these days, man, one of these days. Input 0 is incompatible with layer LSTM. Expected ndim equals 3, found ndim equals 4. Really? Oh, well, yeah. I probably don't have to specify that first dimension. Let's do that. There we go. Look at that. Much better, much better. Okay, let's compile. Let's try this one more time. Again, hopefully this does not take forever to compile. Hopefully by taking out the massive embeddings, we'll save ourselves some headache. Working with Keras, always fun. Hey, things are happening. What do you know? This will take a minute and a half. What is our accuracy currently? About 30%. Ever so slightly better than random, but we've looked at a very small section of data. So that's actually pretty cool, and this is climbing steadily. I want to see what the validation accuracy is, so I will wait out the extra minute to see how this goes for the first, just the first epic here. And accuracy is climbing very well. I'm a fan. I'm definitely a fan. I like it. I like it. This is good. This is very good. Ugh. Alright, well that almost was a botch. But I think in the end this succeeded reasonably well. And this was just the first model that came to mind. Well, the first recurrent model that we were able to implement. So I don't need this embedding. Just get rid of that. Embedding is for when you've got a whole bunch of indices of like words are your features. Which words do you have? Yeah, so that's just a convenience function. Rather than sticking in all your features being what word is this? Is it this word? Yes, no. Is it this word? Yes, no. Is it this word? Yes, no. That's sort of the obvious embedding. Ugh. Alright, one epic, it looks like we're going to reach about 50% accuracy. Did it like splits through several of these while I wasn't paying attention? It might have. I want to see what the validation accuracy does though. Show me better than 20%. Show me the money. Show me the money. Come on. Big money, big money, big money. No whammies, no whammies, no whammies. Stop! Keep hitting that, saving out the weights. This all takes a lot of time. I might try to build this model a little better. Yeah, so next week, I'll be back, possibly for the final episode of For Well Thou Knowest, where I'm going to try to improve this model a little bit, hopefully make it a little bit faster. Validation accuracy, 70%. Not bad for a pretty simple first pass in the model. And it's getting better in the training as well. So yes, so next week, I think we're going to be able to complete that. We're going to add a convolutional layer to our input and then pass in that to our recurrent layer and see if we can get something even better out of this. I suspect that we can, and we can get a slightly more intelligent model with a very small number of features that can train quickly and still be very accurate and not eat up all your memory, say. So that is all I got for tonight. Thanks to everyone for coming out. Again, I'm super glad to be back. And one last time, since I have to plug it, I don't have to, but I choose to. Last week, I published a video series on deep learning with TensorFlow. So if you're super interested in that, or if you think you might be interested with TensorFlow, feel free to check that out. All right, stay safe in the data mines.